friends, welcome to our channel ecabeyaantrix. In this video, we are going to learn about photodiode in lecture number 8 of electronic devices series. Okay, so mainly what is a photodiode, what are the different types of photodiode and what is the operation and VA characteristics and its applications. Okay, so we are going to learn about these in detail and also the important performance parameters of photodiode and what is the main differences between photodiode and other diodes. Okay, so we can learn about these in this video particularly. Okay, so watch this video till the end for better understanding. Okay, so come, let's start the video. If you haven't subscribed to our channel, do click the subscribe button and press the bell icon for further updates. Come, let's start the video. Okay, so what do you mean by photodiode? Okay, so photodiode is actually a PN junction diode which is used in reverse bias condition, because in forward bias it acts as a normal PN junction diode only. So it's not widely beneficial in its forward bias mode. Actually, it has two main modes such as reverse bias mode and high reverse bias mode actually. Okay, so in reverse bias condition it is widely used. Okay, so but it acts as a normal PN junction diode in forward bias mode also. Okay. And what do you mean by photodiode actually? So the name itself implies that photodiode. Okay, so that is photo means light, right? So when light is incident on this photodiode, it generates current. Okay, that actually it means it generates electron hole pairs which generates current, obviously, right? So that the amount of current generated is directly proportional to the intensity of light fall on the photodiode actually, right? So but the structure is similar to a PN junction diode only, but the main difference is that light is incident on the PN junction so that it generates electron hole pairs, and as a result the photocurrent is generated. Why I am saying photocurrent means since that current is generated using light, that is by means of photons, right? So hence it is called as photocurrent. Okay, and that current varies with the incident light, right? That is the number of photons on the photodiode, right? So the current varies with the incident light or number of photons. Okay, and as a result the light energy is converted into electrical energy, right? So this device hence it is called as photodiode, right? And the main working principle is photovoltaic effect. Okay, because the light is converted into electrical energy, right? So hence the effect is named as photovoltaic effect, right? And due to this property, it is also known as light sensor because it acts as a sensor also. What is a sensor actually does? A sensor actually senses some signal, right? And converts it into another signal or so on, right? So the main purpose is it sends or detects the signal, right? So in this photodiode, the light is sensed, right? So hence it is called as light sensor or photo detector or light dependent diode, right? And this is the symbol of a photodiode, right? Photo means light, right? So the photons get incident on the PN junction diode, that is this photodiode, right? So because the symbol coming to the symbol, it's very similar to a PN junction diode. The only difference is this symbol, right? These two arrows which indicates that the light is incident on the PN junction. So as a result, the electron hole pairs are generated, and due to that, a current is generated, which is called as photocurrent. மற்றபடி இது எல்லாமே சேம் தான் as a PN junction diode. Okay, anode, cathode, ரெண்டு terminal அதெல்லாமே சேம் தான். ஓகேவா? Okay, next coming to types of photodiode. Actually, there are two types of photodiode, pin photodiode and APD photodiode. Pin means, as we have dealt about pin diode, right? Pin diode in the previous lectures here. Do you remember that pin stands for P-type semiconductor, N-type, and I stands for intrinsic layer, right? And in some types of photodiode, the intrinsic layer is present between the P-type and N-type, right? Okay, so அங்க பின்ல என்ன கான்செப்ட் பார்த்தோமோ அதே கான்செப்ட் தான். எப்படி PN junction diode நம்ம ஒரு போட்டோ டயோடா நம்ம யூஸ் பண்றோம்னு நீங்க சொல்றோமோ அதே மாதிரி தான் பின் போட்டோ டயோடையும் நம்ம அதே கான்செப்டை நீங்க யூஸ் பண்ணிக்கலாம். கன்ஸ்ட்ரக்ஷன் எப்படி இருக்கும்? பின் டயோட் மாதிரி இருக்கும், பட் லைட் இஸ் இன்சிடென்ட் ஆன் தி depletion layer, that is between the P type and N type. இந்த PN junction மேல லைட் வந்து இன்சிடென்ட் ஆகுற மாதிரி வச்சிருப்பாங்க. ஓகேவா? ஸோ இந்த பின் போட்டோடயோட் இஸ் யூஸ்வலி யூஸ்ட் இன் ஸ்டாண்டர்ட் ரிசீவர்ஸ். ஓகேவா? ஸோ ரிசீவர் சைட்ல யூஸ் பண்ணிப்பாங்க. மற்றபடி இந்த பின் photodiode converts the light energy into electrical energy. Okay, so the only difference is an intrinsic layer is present between the P-type and N-type, right? Method the same concept, converts light into electrical signals with high switching speed, as we have learnt about pin diode in our early videos. Do you remember the concept? Pin diode is mainly used in RF switching circuits, right? I have compared with the other diodes also, right? So the while hearing this RF switching word, you have to remember this pin diode, right? So the same application only for a pin photodiode also, because it is used with high switching speed and with low noise. So this is the main uses, right? So the main key uses this low noise here. Okay, so the pin photodiode is mainly used for the purpose of reducing the noise, right? And coming to the second type of photodiode, that is avalanche photodiode, APD, right? So it offers internal gain. Okay, so the internal gain can be increased using this APD, and for long distance links and low power signals, it improves the sensitivity. The APD stands for avalanche photodiode, and it improves the sensitivity for in case of long distance communication, and if the signal power is too low but I have to transmit to a larger distance, means we can definitely use avalanche photodiode using the same light concept only. But what is the main concept of this avalanche means, we have learnt about avalanche breakdown in Senor diode concept, right? The same logic here. Okay, so due to the avalanche multiplication, that is we know that when light is incident on a photodiode, obviously the electron hole pass generated, right? And as a result photocurrent is generated, right? And as a result the electron hole pass generated bombards with or gets strike with the neighboring ions, and as a result the avalanche multiplication happens. Okay, but அந்த multiplication நடக்கிறதுனால, that is avalanche multiplication நடக்கிறதுனால avalanche photodiode னு சொல்றோம். This avalanche photodiode is mainly useful in larger reverse voltage. Okay, so as I said earlier, photodiode, that photodiode nale it's widely used in reverse bias operation only, right? At that time itself I have said that there are two modes, reverse bias mode and high reverse bias mode. This pin photodiode is mainly useful in reverse bias mode. This avalanche photodiode is mainly useful in high reverse bias mode. When we increase the reverse voltage to a larger level, avalanche multiplication gradually happens, and as a result, the photocurrent is generated in this avalanche photodiode. Okay, so got the point? So that's the main difference between the two types of photodiodes, right? And coming to its structure, PN photodiode structure. Okay, so as I said earlier, there will be P-type material and N-type, similar to a PN junction diode only, and there will be a depletion region in between. I have said this in a PN junction diode concept itself, right? And anode, cathode, two terminals, and here there will be a anti-reflective material coated, right? Anti-reflective material, and here as usual there will be a silica diffusion, right? And this anti-reflective material, the purpose of this anti-reflective material is that we have to get the light or the photons incident on a particular layer only. Okay, so we no need to get the light incident on the entire layer. We need to get the light incident on a particular layer only. Hence, anti-reflective material is coated above this, right? And this is the active area. And the other concepts are similar to a PN junction diode only, right? And coming to this VA characteristics, I will explain in the further slides. And this is the working of photodiode, right? The P-type semiconductor, N-type semiconductor. This will be a depletion region, PN junction, right? And in this PN junction only light is incident, right? And as a result, what do you mean by light? Light is incident means photons are emitted, right? Photons are strike in the depletion region or PN junction, right? And as a result of this photons, okay, as a result of this photon striking on this PN junction, there will be electron hole pairs generated, and due to this movement of electron hole pairs, it results in a current called photocurrent, right? And if we apply in the diagram உங்களுக்கு பார்த்தா தெரியும், anode is the positive terminal, right? Positive terminal is connected to negative terminal of the battery, and here the negative terminal is connected to positive terminal of the battery. That is, this operation is reverse bias operation. As I have said earlier, photodiode mainly is useful in reverse bias mode. That too, in high reverse bias mode, more amount of photocurrent is generated. That is in avalanche mode. Okay, we can say that mode as avalanche mode. That is high reverse bias mode, right? And coming to VA characteristics, right? In VA characteristics, okay, so about that working, before that we can learn about working. As I said earlier, there are two types of mode, right? Reverse bias, high reverse bias. In reverse bias mode, it operates as a normal photodiode. In high reverse bias mode, it acts as a avalanche photodiode, or we can say that mode as avalanche mode of operation, right? Other than that, it works as a normal PN junction diode in forward bias operation. The only difference is light is incident on the PN junction, okay? And even though if we didn't apply any incident light, okay, if there is no incident light on the PN junction, there will be a negligible amount of current flow. That current is called as dark current. Okay, the current through the photodiode when there is no incident light is called as dark current, right? And as a result of this, the photon striking the depletion region generate electron hole pairs, right? So the photons means the light, right? Because the light contains packets of photons, right? And as a result of photons striking the depletion region or the PN junction, it generates electron hole pairs. Okay, so under high reverse bias voltage mode, the electron hole pairs gets accelerated under high electric field and it gets enough energy to ionize other neighboring atoms too. Okay, so as a result, more carriers are generated and more amount of photocurrent flow also. Okay, so this mode is called as avalanche mode of operation, right? So this is all about working, right? And coming to performance parameters. Okay, so there are three types of performance parameters. So these parameters are very important for checking the efficiency of a photodiode, right? And coming to the first parameter, response time, right? What I mean by response time means time taken for the charge carriers generated by incident light to cross the depletion region, right? So we have making the incident light to get strike on the PN junction or depletion region, right? And as a result, the charge carriers will be generated. Okay, that's all the concept, right? And the time taken for the charge carriers to cross the depletion region is called as response time. Okay, and the second point is about responsivity. Okay, so how it responds to the optical power and generates it to a, and that is, it converts it to a electrical current. That efficiency, that how effectively it converts the incident optical power into electrical current, that parameter is called as responsivity, right? And the third parameter is breakdown voltage. Okay, so this voltage is the reverse voltage, that is the maximum allowable reverse voltage that can be applied to your photodiode before it enters avalanche breakdown. Okay, so that maximum threshold voltage is called as, that maximum reverse voltage is called as breakdown voltage. And after that breakdown voltage, it enters the another mode of operation called avalanche breakdown, and it generates more amount of photocarriers, right? And as a result, more amount of photocurrent gets flowed into the photodiode, right? Okay, and coming to VA characteristics, right? And as I said earlier, the photodiode is mainly used in reverse bias operation, right? And as we increase the reverse bias voltage, now gradually the current also gets increased, right? The current also gets increased. And coming to this dark current, as I said earlier, even though there is no incident light applied on the photodiode, there will be a small leakage current or reverse saturation current. Okay, so that current is called as dark current. The meaning dark implies that absence of light, right? So hence it is called as dark current. மற்றபடி இது நீங்க லீக்கேஜ் கரண்ட் ஆர் ரிவர்ஸ் சேச்சுரேஷன் கரண்ட் அந்த மாதிரி கூட நீங்க சொல்லிக்கலாம். ஓகேவா? ஸோ மற்றபடி நீங்க என்ன பண்றீங்கன்னா, உங்களுக்கு அந்த இன்டென்சிட்டி கூட கூட, அதாவது அமௌண்ட் ஆஃப் இன்சிடென்ட் லைட், அந்த இன்டென்சிட்டி ஆஃப் இன்சிடென்ட் லைட் கூட கூட, நம்பர் ஆஃப் ஃபோட்டான்ஸ் கூட கூட, தி ஃபோட்டோ கரண்ட் ஜென்ரேட்டட் ஆல்சோ வில் பி இன்க்ரீஸ்ட், ரைட்? அண்ட் கமிங் டு திஸ் diagram, if you increase the incident light to 10,000 lux. What do you mean by lux? Lux is actually the unit of illuminance. Actually, what is illuminance? Illuminance is nothing but the light incident on the photodiode, right? And the that unit is called as lux, right? And the 10,000 lux means we are increasing the light intensity to 10,000 value, right? ஓகே, ஸோ அந்த டைம் என்ன நடக்குதுன்னா, ஃபோட்டோ கரண்ட் கொஞ்சம் கூடி இருக்கு, கரெக்டா? ஸோ டார்க் கரண்டை விட ஆப்வியஸ்லி கூடி இருக்கு. இதே இது நம்ம 15,000 இன்க்ரீஸ் பண்ணும்போது தி ஃபோட்டோ கரண்ட் கிராஜுவலி இன்க்ரீசஸ், ரைட்? அண்ட் தி சிமிலர் கான்செப்ட். ஓகே, ஸோ தட் விச் மீன்ஸ் இஃப் யூ இன்க்ரீஸ் தி illuminance, right? So if you increase the number of photons, or if you increase the incident light, or if you increase the intensity of light, okay, so gradually the photocurrent amount also is increased. Okay, so the lux is nothing but measure of light intensity falling on the photodiode. Okay, so for example, if we say that 20 microampere is generated at 100 lux, means at 100 lux, that is at 100 that's a light intensity measure, right? At 100 lux, 20 microampere photocurrent is generated. So by that parameter, we can say that, okay, this is a normal photodiode. I need a better photodiode, means we need to check the specification in the photodiode. Okay, okay, so that's the main concept in the VA characteristics. Keep this point in mind as a main logic, right? Okay, And coming to applications. Okay, so where all we are using this photodiode means mainly it is used as a light detector. Okay, so if we need to sense whether a light is fallen on the device or not, we can obviously use this photodiode. Okay, and it can also used as a light activated switch also. And it's mainly used in optical communication because optics means light, right? So wherever optical communication is used, definitely there will be a use of photodiode. Okay, and the group of photodiodes only form a solar cell. Okay, so we can learn about that solar cell in our next video, right? So that's the main important point in the photodiode concept. Hope you understood this video clearly. Okay, so maintain the notes of all the topics undertaken so far. Okay, so if you have any doubts, do drop your doubts in the comment section. I'll definitely help. And I have mentioned my email ID also in the description. You can take that help also, right? And okay, that's all about in today's video. I have included an MCQ also in the comment section. So kindly attend that MCQ also. So for a better satisfaction of me, okay. So we can meet in the next video. So if you haven't subscribed to our channel, do click the subscribe button and press the bell icon for further updates. We can meet in the next video. Until then, thank you.